By the way, we wait for a while, about 20 minutes, to finish the main presentation in the auditorium. We started in 20 minutes later, so this is the first presentation. So now is the second presentation. So please welcome the Hasan, who is presenting assessment of aquifer storage and recovery efficiency in coastal aquifers.
Hello everybody, my name is Mohammad Hasan. I am doing my PhD in TU Delft. Part of my research is concerning about the aquifer storage and recovery efficiency. My project is called ISMAR, which is funded by NWO from Netherlands. In this research, I will develop a new tool, which main concern of this tool is to maximize the recovery efficiency in coastal areas. The main assumption of this tool is this tool doesn't require complex flow transport model. This is based on only Dupuit approximation. Different cases will be investigated to see how we can maximize the efficiency. First assumption is that we assume the vertical pie slice. At the top of the interface is called the tip, which touches the top, and at the bottom it is called toe. Two distinct density can handle this tool. One is fresh and another is saline. Interface flow is considered. The density effect is considered through Darcy's law. Dispersion and diffusions are neglected. The main theory is adopted from Baca 2003 for vertical movement of the interface. Finite difference method and implicit schemes are applied. Axisymmetric approach is adopted from the Langevin 2008. The main concern if I want to apply the model in local scale is the toe and tip, because in regional scale it doesn't really matter if we assume some average slope, but in local scale it really matters. So the algorithm is taken from Baca 2013. There are some modification applied after the adaptation. The main modification is applied is that this model can change the slope by itself depending on previous time steps interface slope. At first, the model starts with some user specified value. Then the model changes its slope by its own. There are three types of model available at this moment, which can do the same thing as my tool is doing, but there are differences. Say, the tool from Baca 2010 is developed for isotropic model. So the heterogeneous model cannot handle by this tool. My tool, our tool can handle heterogeneous aquifer. And this tool cannot simulate multiple layers, but our tool can handle. There are also another tool available, which is called SWI2, which runs along with ModFlow. The main difference with the SWI2 module is that it cannot change the toe tip slope by itself. Our tool can change the toe tip slope. So at first we assumed aquifer of 20-meter depth, and the injection and recovery is done over the whole layer of the aquifer. If we see the water balance, we can see that this is reasonably accurate, which is more or less than 0.016 error. And efficiency, the model has run up to 10 cycles. At 10 cycles, it achieves 74% of the recovery. And same thing is simulated on SWI2 module, which is 76%. So we can see the model is working good. Now if you see the profiles, what is happening, at the first we started to inject the fresh water, and where is the laser? The interface is going out from the well. After that, the recovery is conducted. When the interface touches the bottom of the recovery well, then we stopped the recovery. It is conducted up to 10 cycles to achieve how the recovery efficiency increases. The profiles are superimposed with other tools results, and we can see that the tools is working very good. Now you can see that as the time goes, more the fresh water remains in the aquifer, the interface starts to incline, and this is due to the buoyancy effect. The fresh water is lighter, so it goes up to the aquifer, and the main reason the recovery efficiency is decreasing is due to this. So if we learn this scenario and apply a better scenario, that if we put the recovery well somewhere middle in the aquifer, next case we considered this. We put the recovery well at the middle of the aquifer and also injected at the middle. The recovery and the injection rate is taken 2000 meter cube per day. And in this scenario, the water balance is also good, which is error is less than 0.028%. And in this scenario, we actually increased the recovery efficiency 74 to 79%. So in this scenario, we actually have increased the recovery efficiency. Now, if we want to increase the recovery efficiency a bit more, we in this the results are here, and we have superimposed the previous case with this. Now we can see the difference what is happening in this two-layer scenario. The lower portion is the recovery after the end of recovery, and you can see in first case the recovery is stopped when the interface touches the bottom of the aquifer, and the second case the recovery well is at the middle depth of the aquifer. So we have a lot of chance to recover more fresh water in this case. The third case, we actually injected water at the bottom of the aquifer and recovered from the top. So in this case, we actually increased the recovery efficiency up to 81%, which is better than the previous one. And the results you can see, this is also superimposed with the single layer model. So in this case, we are also increasing a bit more recovery efficiency. If we want to conclude now, this is actually more or less a new for radial flow. The theory is taken from the Baca 2003 paper and Langevin 2008. This tool can simulate two-layer model. For two-layer model actually shows better recovery efficiency, and the model actually produces pretty much similar results with the existing tools, but the difference is this model works a lot faster. If we want to go implement more complex scenario, this tool needs more development. Thank you for everyone.
We have time for questions. Couple of things. Yeah.
Yeah, sure. This is the radial model, 3D, but the whale is at the left part. This.
Would you use the microphones, please? Thank you.
In relation to the interface, where is
Yeah.
the well situated?
Well situated, you can. It's the left side of the figure. This is the radial model.
Yeah, I understand.
I'm only-
okay,
yeah.
on the vertical axis.
On the vertical.
And
axis,
how
yeah.
deep is it? The total all the way.
This is 20-meter deep aquifer. Yeah.
Thanks for your talk. Well, the difficulty with ASR
Yeah.
in brackish groundwater environments, of course, is the recovery efficiency, like
Yeah.
you explained. We're dealing that now with multiple screens, and not just multiple screens for recovery, but also using those multiple screens for injection in that way, controlling. We use a lot of CWAT modeling, which of course takes time,
Takes time,
runtime. This is much faster.
Yeah.
What do you expect? Can you modify your analytical solutions in such a way that you can make them more adjustable for adjusting pumping rates and injection rates over multiple filters? Or is that too complicated for
No,
for
it
the
can be
analytical
done. normally the flow is distributed with the existing equation over the whole depth. When I put in the middle the screen, then it distribute over the top. When I put in the bottom, it distribute full. So it can be handled.
Thanks.
Others? I have one
Sure.
question. So, yesterday, the David Pine has a presentation about the ASL in Florida to mitigate the saltwater intrusion, and he says he recovered almost 100% of injected water, but you're not agree on that, I think. So, is there any?
Is it the freshwater aquifer or the saline aquifer? I guess it's freshwater. In freshwater, it's lots easier.
It's
Freshwater
the,
aquifer.
The Florida
Yeah.
is saltwater aquifer and pushed out the saltwater.
Okay.
And it's confined aquifer.
Oh.
So it's unconfined scenario.
This is confined scenario.
confined.
Yeah.
Confined scenario.
For freshwater, 100% recovery efficiency can be achieved. But in saline aquifer, there are a lot of complications. And I am also investigating scenarios which can be achieved 80%, 90%. It's still not yet there.
Yeah. So did you do some sensitivity analysis when you are modeling?
Sorry, that
Sensitivity analysis.
sensitivity analysis.
Yeah.
I will do it later.
You
Okay, it's also
Yeah.
it's still developing.
Yeah, please find out what kind of
Yeah,
condition
yeah.
is the condition
Yeah.
that we recovered almost 100%.
Yeah. Thank you.
Thank you. Any other questions? Okay, please big applause to Hasan.